Good evening and welcome to this video for product rule, and this is for level 3 calculus, level 3 differentiation. Alright, so the product rule. The product rule is used to differentiate a function. In this case, this is when a function has two parts and these two parts are multiplied together to form a product. The key thing about both of these parts is that both must be a function of the variable that it refers to. For example, if it's f of x, then both of these parts need to contain the variable x. On the other hand, if it's f of z, for example, then both parts must contain the variable z. So both parts have to contain the variable that the function is referring to. So the formula sheet on level 3 calculus, it's printed the product rule as, so it has f times g bracket, so the derivative of f times g equals to the function f times of the derivative of g plus g times the derivative of f. So this formula states that if two parts of a function are multiplied, the derivative of the function as a whole is the derivative of the first part multiplied by the second part, and vice versa. So we have to consider both of them. So the two parts of the differentiation would be the derivative of the first part times the non-derivative of the second part plus the derivative of the second part times the non-derivative of the first part. Alright, so here are a couple examples. So consider the function f of x equals to 2x times e to the power of x. Alright, so looking at this equation, we can see that this is a function of x because it's f of x, and that the two parts of the equation is, part 1, we can see it's 2x, and part 2 would be e to the power of x. So once we see these two parts, we can actually directly apply the product rule. So applying the product rule, if we have 2x times e to the power of x, so our product rule states that the derivative of the function is the derivative of the first part multiplied by the non-derivative of the second part plus the derivative of the second part times by the non-derivative of the first part. So the derivative of 2x is just 2. So the first part of our equation is just 2e to the power of x. The derivative of the second part, e to the power of x, derivative of e to the power of x, that's still e to the power of x. So the second part of the derivative would be 2x times e to the power of x. Combining these two, we will get the gradient function, which is f dash of x equals to 2e to the power of x plus 2x e to the power of x. Alright, so now let's say the function f of x equals to 2x sine 45. So even though 2x is being multiplied by sine 45, and some people might argue that since you're multiplying these two things together, then that must be a product. Well, technically, because sine 45, that's not a function of x, and this means it cannot be treated as a quote-unquote part in the equation. It's a constant. So sine 45, it's actually, if it's in degrees, then it's actually root 2 over 2. It's not actually a function of x, it's just a constant. Therefore, it does not count as a part. So as I said in the first slide, a part only counts if it's a variable of that function. So in this case, f of x, both parts have to be functions of x. Alright, so here are a couple of walkthrough examples. So f of x equals to x squared times of ln of x. So we're going to put out our g of x and h of x. So g of x and h of x are just representing our two parts in this case. So g of x would be our x squared and h of x would be our ln of x. On the other hand, we're going to differentiate both of these parts. So g dash of x becomes, g dash of x becomes 2x. Derivative of x squared is 2x. The derivative of ln of x is 1 over x, so h dash of x is 1 over x. So in this case, once you have this drawn out, you can actually just say that the derivative is g of x times h dash of x plus g dash of x times h of x. So if we drew arrows here, then we could see where the two parts of this equation was. So the first arrow, g of x times of h dash of x, so that's x squared times 1 over x, plus h of x times g dash of x, which is ln of x times 2x. So therefore, combining these two parts, we'll get f dash of x equals to 2x ln of x plus x, because x squared over x is just x. So question number 2, f dash of x equals to tan x times of sine x. So in this case, we're going to locate our two parts of the equation, and we're going to write down our g of x and our h of x. So our g of x in this case, well, it doesn't really matter which way you do it. So g of x could be either tan x or sine x. It doesn't really matter. You can switch them around. So in this case, g of x, I've said to be is tan of x, and h of x is sine of x. If we take the derivative of both of these functions, we'll get g dash of x equals to secant squared of x, and h dash of x equals to cos x. So once again, applying our product rule, we can draw two of our arrow lines. So we'll see that the first part of the equation is tan x times of cos x, and our second part of the equation is secant squared of x times of sin x. And once we just need to put these two together, and we'll get that f dash of x equals to sin x times secant squared of x plus tan x plus sin x times secant squared x plus tan x times cos x. Right, so here's a few practice questions. So f dash of x equals to 3x minus 3 bracket times 8x cubed minus 2x squared plus 5x minus 1. So for these practice questions, I want you to pause the video and try the question for yourself, and when you're ready, keep watching the video. Alright, so for this first question, we have our two parts of our equation. So our first part would be 3x minus 3, and our second part would be 8x cubed minus 2x squared plus 5x minus 1. So the derivative of 3x minus 3, that's just 3. And we can say that the derivative of 8x cubed minus 2x squared plus 5x minus 1, that is 24x squared minus 4x plus 5. So once we have these two parts, we can actually combine them. So our derivative therefore would be 3 times of 8x cubed minus 2x squared plus 5x minus 1, plus our second part of our derivative, which is 3x minus 3 bracket times 24x squared minus 4x plus 5. And that's our derivative. Question 2, f of x equals to 7x times e to the power of x squared. Once again, pause the video and keep watching when you're ready. Right, so for this question, we can once again identify our two parts. Our first part will be the 7x, and our second part will be e to the power of x squared. The derivative of 7x is just 7, and the derivative of e to the power of x squared is 2x times e to the power of x squared. Therefore, our derivative would be 7 times e to the power of x squared plus 7x times 2x e to the power of x squared. And if we times 7x and 2x, we get 14x squared. So our final answer is f dash of x equals to 7 e to the power of x squared plus 14x squared e to the power of x squared. Question number 3, we have f of x equals to bracket x plus 3 to the power of 4 times sine of 3x. For this question, we're going to have to use the product rule with the chain rule as well, because we have a function within a function, and we have two functions multiplied together, so we have to combine the two. However, there's not much change. So for this question, our first part of the equation, our first part is our x plus 3 to the power of 4. That's one part of the equation, and our second part of the equation is sine of 3x. So once again, all we need to do is differentiate both of these. We need to differentiate x plus 3 to the power of 4, and we need to differentiate sine of 3x. The derivative of x plus 3 to the power of 4, that's 4 times of x to the power, that's 4 times of x plus 3 to the power of 3. Derivative of sine 3x is 3 times of cos 3x. And that's just applying the chain rule. So once again, if we just combine these parts using the product rule, we'll get that f dash of x equals to 4 times of x plus 3 to the power of 3 times sine 3x plus 3 times of x plus 3 to the power of 4 times cos 3x. And that should be our final answer. For our last question we have here, we have f of x equals to square root of 1 plus 3x times x cubed minus 7x squared. So once again, for the square root part, we're going to rewrite the square root as to the power of 1/2. So it becomes 1 plus 3x to the power of 1/2. Then we can apply our chain rule to find the derivative. So the derivative of 1 plus 3x is just 1/2 times bracket 1 plus 3x to the power of negative 1/2 times the inner function, which is 3. For the second part of the equation, we have x cubed minus 7x squared. The derivative is just 3x squared minus 14x. So once you have both of these derivatives, you can actually not necessarily cross multiply, but you can combine the two parts, and you should get that f dash of x that equals to 3x squared minus 14x square root of 1 plus 3x plus 1/2 of x cubed minus 7x squared over square root of 1 plus 3x. So for this answer, I actually forgot to put the 3 after the second part, so it should be 1/2 So actually it should be 3 halves, so 3 over 2 times x cubed minus 7x squared over square root of 1 plus 3x, and that's because I forgot to multiply by the 3, which is inside the square root. So I apologize for that, but we should have 3 over 2 bracket x cubed minus 7x squared over square root of 1 plus 3x. Right, so we also can consider more than 2 parts multiplied together. So in the previous questions, we were only looking at, for example, 2 of the 2 parts multiplied together. However, a scholarship concept can be using a three-way product rule, which is 3 product multiplied together, which is pretty self-explanatory. So for the three-way product rule, it's actually very similar because when we have 3 parts, or we follow the exact same process. We're going to differentiate each part separately, and for each one we're going to find the derivative of one of the parts multiplied by the non-derivatives of the other 2 parts, and we're going to do that for every single part. So basically we're going to have 3 terms instead of 2, because for 2 parts we only end up with something plus something as our derivative, but for the 3 parts equation we'll get something plus something plus something, so we'll have 3 terms in the equation. So as I say here, so with the product rule, no matter how many parts there are, remember that always differentiate one part of the equation and multiply it with 2, not necessarily 2, but with all the other undifferentiated parts, and we're going to be doing this for each part. Therefore, for the three-way product rule, there will be 3 terms. For the 4-way, there will be 4 terms. For the 5-way, there will be 5 terms, etc. So our formula is actually f dash if we have a function g times a function h times a function k, we'll get g dash h times k plus g h dash k plus g h k dash. So as you can see here, for each of these terms, only one of the functions are actually differentiated, and all the other ones are the non-differentiated terms, okay? And then we're going to be doing that for every single term. So like I said, so for three-way product rule, there'll be 3 terms. For 4-way, there'll be 4 terms, etc. Right, so here's an example question. So if we have f of x equals to 2x times sine of x times ln of x. So that's going to be our 3 parts. Part 1 is 2x, part 2 is sine x, part 3 is ln of x. So in this case, we're going to draw out our g of x, h of x, and k of x. So in this case, it doesn't really matter what g of x is. It could be z of x, could be a of x, could be b of x. It doesn't really matter, okay? It can be anything. So g of x, in this case, I've said to be 2x. H of x, I've said to be sine x. K of x, I've said to be ln of x. We're going to draw our different derivatives on the right-hand side here. So g dash of x, derivative of 2x is just 2. H dash of x, derivative of sine x is cos x. And k dash of x, derivative of ln of x is 1 over x. So now we have our non-differentiated functions and our differentiated functions. So now to visualize this, we're going to have arrows. So our first term would be g dash of x times h of x times k of x. In other words, it will be 2 times of sine x times of ln of x. That's our first term. Our second term will be moving down the chain, so we'll go down to h dash of x. In this case, h dash of x multiplied by g of x multiplied by k of x. So our second term would be cos of x times 2x times of ln of x. Times of ln of x. Okay, so for our third, we have k dash of x. So in this case, our term would be 2x times 1 over x plus of sine of x times 1 over x. So our final f dash of x should be 2 sine of x, ln of x, 2 times of sine of x times ln of x, that's our first term, plus our 2x times cos x times ln of x, that's our second term, and our third term is simply just 2 sine of x. And that's because 1 over x times 2x, that the x's cancel out, so you just get left with 2, and 2 times of sine x is 2 sine of x. So in this case, that would be an example of how you do a three-way product rule. So for a four-way product rule, it's very similar. Instead of 3, you'll just have 4. So you just have more terms multiplied together. So as there are more and more terms, your equation, your derivative might get more and more complex, but the number of terms only increases by 1. So If we have a three-way product rule, it's 3. If it's a four-way product rule, it's always 4 terms. If it's a five-way product rule, it's always just 5 terms. And always follow the rules. So remember, for each term, you're only differentiating one part, and you are multiplying the differentiated part that you just differentiated with the other non-differentiated parts. Okay, so for each term, there's only one part that's differentiated. All the other parts should be the same as what you had in your f of x, undifferentiated. Okay. So just remember to move down the line, and you have to do this with all of the parts, and once you finish doing that with all the parts, you will have your derivative. Alright, so thank you for watching this video. I hope you enjoyed, and I hope to see you all in the next one. Thank you. Bye.